Howdy again, it's Mr. Pete, your YouTube shop teacher. I'm sitting here at my little UNIMAT lathe having fun with it, and I'm going to make my first little project, and I do mean little, right now in this video. A friend of mine needs 6 of these little hex head screws or bolts made out of brass. They're 632 in size, and I've already made a prototype and it turned out just fine. So in this video I'm going to show you a few things that are new to this machine, and then we'll make this screw and turn to diameter and do a little threading and facing, but the threading will be done with a die because I do not have the threading attachment for this, but it's going to be just fine. So let's begin. So let me talk about the 4 little improvements that I've made. These are the Tommy bars that came with the UNIMAT, and they're used to tighten the 3-jaw chuck in a manner like this. But what I don't like about these is they're too short, you don't have the leverage, and the diameter is too small. So I took the liberty of making a pair of Tommy bars out of 1/4-inch stock using, I believe it's a number 19 drill shank there, because they're hardened, and so it gives me the extra leverage that I desire to open and close the chuck. You might want to do that as well. Now compare these with, where did I put the originals? So you can see there's quite a bit of difference in size. Next, I do not really like the switch here because you got to reach over for it. And my fingers are fairly near the belt, so it's kind of dangerous. You could cut yourself, I suppose. So from Scamazon, I ordered this little foot switch, and I think it was 12 bucks only. I kind of like it because you don't have to lift your foot. Just tap your toe on here and it's on and off, although it can be a little tricky. That you want to make sure you don't hit this switch while you got your hands someplace around the moving parts. So beware of that, but this sure is handy. And next I submit for your approval a little carriage stop that I made. So it's just a piece of aluminum and is reamed 12 millimeters. I had to buy a reamer for that. And the little set screw here has a brass tip on it so it will not mar the rail, but that way I can feed to a certain depth after determined and just snug that up, and the carriage is going to strike that, and I will be using this stop in this video. Let me explain something to you. This machine was made in Austria, so everything is metric. So the lead screw right here is 8 millimeter with a 1 millimeter pitch. That means that one full turn will move the tool in 1 millimeter, but it means it would take off 2 millimeters. Now I want to work in inches, so one full turn in inches would be 40 thousandths, but that would take off 80 thousandths. You understand we're taking material off of both sides. That's why I'm doubling it. You probably know that. Well, what does that all mean? It means that for each graduation that we move in on the dial here, we're going to take off 2 thousandths, but actually 4 thousandths because we got to double it. Now that's only semi-accurate, and that is why I have installed this dial indicator. So take a look at how I did this. So here's my setup. First of all, this is a very small dial indicator, 1.5 inch diameter. You don't really want to use a big bodacious thing like this, all you could. And then the other thing is I didn't have the reach that I needed right here, so I took off the original tip and put on an extension, which is what you see right here, and that's touching up against the cross slide here. Now I have it mounted on my smallest little Noga type. This is Chinese, of course, so it's very compact, and I have a temporary steel plate back here for the magnet. So you can see the setup there, and let me turn in here and you will see that I can easily watch that little dial and get an exact measurement as I move in. I'm going to use 1/4 inch hex stock brass, and I had a smaller diameter. This is 1/4 inch, but I had some that was one size smaller than this, but it absolutely disappeared on me. It's someplace here, but this is what I'm going to have to use. Now notice that it will not fit into the spindle. So I had a long 12-inch piece of this and I had to cut it off short. This will fit in the chuck, but it won't go very far into the spindle, but that's just fine. Also, you may note I have laid some extra small tools out here that I like to use with this machine. So this is a 1/2-inch stair micrometer, quite small, and I had to cut off one of my die stocks, kind of awkward. And here's my little rule holder that we talked about. Now, if you don't have one of these, many rules have a little rule on the end that you can use for measuring things such as this. But I thought since I made a recent video with this, that I would use that for my measurements. Let's mount the work in the 3-jaw. I've already got a little mark on it, and then I will tighten. Wrong way, Corrigan. Nice little Tommy bars. Let me start by facing or squaring off the end. I've set the tool such that I will be removing, 3/8. So there we go, and now I'll move the stop up, and you won't see this anymore probably. Tighten that down nice, and as you can see, it will strike right here. You might want to make one of these for your machine. This is a learning experience for me. I've never used one of these small lathes before. This is a 632, as I mentioned before, so I need to turn it down to 0.138 inch diameter. And I've already taken, as I said, the cleanup cut here, and I'm at about 200 thousandths, so I have how much left? 62 thousandths about. I realize you can't see the dial very well, but notice that I did zero it out now. And I'm going to move in 15 thousandths, which will take off 30 thousandths, of course. I haven't said anything about the cutting tool yet, but it's a 1/4 inch square, and it's just a standard right-hand turning tool, the same as I use on other machines, although you could use a smaller size if you wanted. So I have one more pass to take, and I need to remove 7 thousandths, so zero out the indicator, and I'm going to feed in 3 thousandths and see how close I am. Right there. Okay, I'm 139 thousandths, so I'm 1 thousandth over. I'll take a tiny little pass. I would rather be under than over, so it would be easier to thread. We don't need a great deal of strength with a brass screw. Okay, I took one more tiny little pass, so I'm 1 thousandth under, which is, I need to be 138 and I'm 137, so that's just where I want to be. Now I'm going to take a needle file and put a little bit of chamfer on there so that the die will catch a little bit easier. This is dangerous, be careful. I wanted to use a tiny little die stock like this with a 632 die in it, but I did not have a die that would fit in this holder. It's a Blue Point. So I took one of my regular 1-inch die stocks and sawed it off. And this side is the side that we will start from. And I want to make sure that I thread perfectly square, so watch what I'm going to do. I'm loosening up the tool block here, and I'm just reversing it. And I want it flush So I'm just going to take a straight edge here, hold it up against, and then move the block in there like that and tighten it. Now this surface is perfectly parallel with the chuck face. I already put a singular drop of oil on the brass, and I'll move the tool block right up against the die stock, and that way I can more or less force it on to start with, so it'll be perfectly square and controllable. Now I will not be doing this under power. It's all going to be hand fed because this brass is very soft and it just doesn't take much to do that. And let me move the camera here just a little bit, and you can see I'm going to be forcing it in at least until it starts. And now moving over here, I'm going to rotate again all by hand, and then I'm feeding. Right now the die holder is up against the rail there, so it has been started. So do you understand why I'm doing this? There are other ways of doing it. Now I don't need this anymore because it's started. Back it off, and I'll continue threading until the end of the die comes right up to the shoulder. And now back it out. Looks good. That is perfect. Now I do not care that there's a little bit of unthreaded portion right here. If you do want to remove that, rethread it with the die backwards in the die stock, and that will get you closer. Next I have to cut the screw off of the brass hexagon stock. Now you can use a hacksaw, but I do have a genuine Edistall cutoff tool. I'm not too crazy about using these, but I'm going to. This is the tool that I used for turning. Let me mount this real quickly. I have moved the work just a little bit out, and I want the head to be 1/8 of an inch, so I have already measured it, and notice that the cutoff tool is in place. Now that's going to make a racket when I first start it until it becomes a continuous cut, so I'm a little leery about this. Okay, that turned out too good to be true, so I'm going to put it in the chuck again like this, face off the end, and then chamfer it ever so lightly, and the job is done. And I forgot to mention that I am running the machine at 1700 RPM. Done. There it is. Well, there it is. Now this is the original one I made as a prototype, and it's a little too long. He wanted to shorten it up, so that's what the final product will look like, and I need to make 5 more of them, but I won't bore you with that. Well, as you can see, it took about 15 minutes to make one of those. On a modern screw machine or a turret lathe or something, these could be made in, what, about 15 seconds or so. But it's fun to do, and like I said, this is the first time I've ever used this machine, and it's a lot better than what I thought it would be. I'm surprised at how accurately I can work as far as turning to diameter. So if you like this kind of video, give me a thumbs up, and there'll be a lot more of them, I hope, and leave a comment. Do you have one of these machines? This is Mr. Pete saying so long. I'll see you next time.